Hello to everyone, and welcome to the ALICE track. My name is Santi Cavaller. I am a professor at the Department of Computer Science of the Open University of Catalonia, which is based in Barcelona, Spain. So together with my colleague Nicola Capuano from the University of Basilicata in Italy, we are very happy and really excited to start a new edition of the track ALICE, which after 10 editions over the last decade, this is actually the first time that our track is allocated in the Learning Ideas Conference. And we would like, of course, to thank and appreciate to the conference organizers for this great opportunity to allocate our track and be part of this excellent conference. So the track ALICE has for today 2 sessions. The first one will start now, and the second session will be held later today after the break. So in this first session, we have 3 excellent talks, all of them addressing more or less the same topic of using conversational agent systems to somehow support the teaching and learning processes in the context of massive online education, or MOOCs. So likewise, previous sessions of the conference, each speaker will have 20-25 minutes for their talks, and then hopefully we'll have 5 minutes, more or less, for questions and discussion. So in any moment of the talk, those from the audience who have questions, please write them in the Zoom question and answers box, so that we all can read the questions and the speaker can answer them. So thank you in advance for your participation and interest. Well, I don't want to steal more time from the speakers and their talks, which is an important thing. So I would like to introduce the first speaker, who is Professor Tim Schlippe.
Yes, perfect,
yes.
perfect.
Thank you.
Thank you.
It's quite complicated for me to pronounce your surname. Thank you very much. So, Professor Schlippe is from the University of Applied Sciences in Thuringen, Germany, and he is a very expert in artificial intelligence and its application to the education domain. So now he will be presenting his research by the talk entitled Artificial Intelligence-Based Interactive Exam Preparation. So I can stop my screen. Let me, and turn over to you. Okay.
Thank you very much, Santi.
Can I start when you are ready?
Okay. Just minimizing that. Okay. Hi, I'm Tim Schlippe, professor for artificial intelligence at IU, International University of Applied Sciences, and also CEO from the company Silicon Surfer. Today, I'm talking about our paper, AI-based multilingual interactive exam preparation. I will start with the motivation, then I will demonstrate some related work of the components which we have in our system. After that, I will walk you through our exam trainer. To evaluate the exam trainer, we conducted a survey. I will demonstrate the results of this survey. And finally, I will sum up and indicate possible future steps. Let's start with the motivation. Access to education is one of people's most important assets, and ensuring inclusive and equitable quality education is goal number 4 of United Nations Sustainable Development Goals. Massive open online courses and other online study opportunities are providing now easier access to education for more and more people around the world. However, one big challenge is still the language barrier. Most courses are offered in English, but only 16% of the world population speaks English. To reach the rest of the people with online study opportunities, courses would need to better support more languages. The linguistic challenge is especially evident in written exams, which are usually not provided in the student's native language. To overcome these inequities, we present and analyze a multilingual interactive conversational AI tutoring system for exam preparation, short multilingual exam trainer. The figure here illustrates the concept of our multilingual exam trainer. Iteratively, an exam question is displayed to the user. For example, here, the computer science question, what is a queue? The user enters the answer called student answer using our chatbot interface. For example, he says, a queue is a data structure that follows the first in, first out principle. Then the student answer is processed with two AI models, the multilingual automatic short answer grading model, short multilingual ASAC model, and the keyword matching model. The multilingual ASAC model delivers quantitative feedback in terms of a score, like here 5 of 5 points. The keyword matching model gives qualitative feedback by displaying the model answer and highlighting the keywords matching the student answer and the model answer. In our example, it is data structure follows or principle. Let's now look at some related work of the components which we have in our system. To allow users of our system to answer the exam questions in their native language, we used a multilingual natural language processing model, short NLP model, and adapted it to the task of grading. Multilingual NLP models are provided by multiple institutions, for example, Google or Facebook. They have the benefit that they can be adapted to a certain task with task-specific labeled text data in one or more languages. This is called transfer learning, and then perform this learned task in other languages, which is called cross-lingual transfer. To give the users of our system qualitative feedback on the answers, we used the multilingual BERT from Google as the basic multilingual model, which is actually pre-trained from monolingual corpora in 104 languages. And we adapted it to the task of cross-lingual automatic short answer grading. As mentioned, automatic short answer grading helps us provide feedback on the student answer in form of a score. The field is becoming recently more relevant since many educational institutions, public and private, already conduct their courses and examinations online. A good overview of approaches in automatic short answer grading before the deep learning era is given in the first paper, Burrows et al. 2014. And the second, the third, and the fourth paper investigate and compare state-of-the-art deep learning techniques for this task. Especially the last paper, which was shown, in that we describe that we conducted the so far largest study concerning the cross-lingual transfer in automatic short answer grading with multilingual BERT in 26 languages. Conversational assistants in education enable learners to access data and services and exchange information by simulating human-like conversations in form of a natural language dialogue on a given topic. For the interaction with the users in our exam trainer, we used a conversational AI that takes the input from the users and sends messages based on a dialogue flow. There are various technologies, frameworks, and services for providing a conversational AI, such as Rasa, Google Dialogflow, or Telegram. Our conversational AI is based on Telegram, since it can be easily integrated into massive open online courses and other online study systems, and has already more than 400 million users worldwide. However, our conversational AI can be ported to other chatbot technologies as well. To explain our users the difference between student answer and model answer, we highlight the keywords and the synonyms which are contained in both the student answer and the model answer. This combines two tasks, keyword extraction and semantic similarity. Good overviews of automatic keyword or key phrase extraction are provided by Hassan 2014 and Maruni et al. 2020. And a survey of the evolution in semantic similarity is given in Chandrasekaran 2021. The latest trend for both tasks is to embed the words into a semantic vector space, thus working with so-called word embeddings, since the semantically similar words are located nearby in such a vector space. As you can see here in the picture, the beverages are close together and the food as well. In our system, spaCy is used to exclude stop words, convert the remaining words into vectors, and compute the word similarities based on the distance in the vector space. To provide our conversational AI's messages in the student's native language, we translated them with the help of Google's neural machine translation system. An overview of the system's Bleu scores over languages is given in Wu et al. 2016 and ICANN 2019. I want to mention that we did not post-correct the translations, as we wanted to check whether our system from scratch already delivers a good user interface in different languages. In order to continuously improve our multilingual automatic short answer grading model with high quality human label training data in a crowdsourcing approach, the user also has the task of scoring another student answer as part of the game. Studies such as Wu et al. 2014 have even shown that peer-based proofreading can be as effective as a professional proofreader. Consequently, the same student answer is demonstrated to different users. Here on the left, you see an example where the user is supposed to evaluate the answer of another student. In this case, memory address of its operand. Given the model answer, the memory address of its operand. That's kind of easy. This peer review process makes it possible to detect and filter outliers, which would have a negative impact on the model. However, on the other hand, this process has another advantage for the user. The student deals with a question again, but this time from a different perspective. Let's now see how our AI-based interactive exam preparation looks in more detail from the user view. This figure shows the dialog flow of our exam trainer. The user first activates the conversational AI in Telegram with a start command. Then the conversational AI welcomes the user and presents a list of languages to select from. The user selects a language. In this case, he or she selected English. The conversational AI asks the user a question in the selected language. In this case, what is a variable? The user types the answer. A variable saves a value at a certain location. Actually, the answer could be in any of the 104 languages used in the multilingual BERT due to the cross-lingual transfer. So you could have answered this answer in German, in French, Italian, and other languages. And it would be created the same way. The conversational AI gives feedback in terms of a score and highlights similarities between student and model answer. If the total points collected are equal or greater than a certain threshold, the goal is reached and the game ends. Congratulations, you successfully landed on Mars. Otherwise, the user is presented with another student answer that he or she needs to score considering the given model answer, and the game continues. To evaluate the exam trainer, we conducted a survey. 51 people from 6 countries filled out our questionnaire, giving us a first impression of the quality and the impact of the system. Most were students from our international university and some other German universities. But they were from different countries, as I mentioned. and most participants were between 18 and 44 years old, open to new technologies for learning, as you could see on the right figure. These people tested our exam trainer in German, English, Dutch, Italian, French, and Spanish. Our study examined different aspects. First, gamification, which refers to the story and the theme, the journey to Mars. User experience, which refers to the ease of use and whether the users had fun. And the quality of the NLP models. How was the translated text? How the scoring quality, and how the keyword highlighting. Furthermore, we asked a lot of questions about the learning experience and motivation. Let's look at the users' feedback. So the figures illustrate the clear majority of participants who like the story and the theme of the game. This demonstrates that even with a simple story like the trip to Mars and without special graphical features, a good gamification can be created. The figures here indicate that a clear majority of participants find that our interface is easy to use, the chatbot interface, and that operating our exam trainer is fun. How was the feedback on our NLP models? In the two figures, we see that the majority rates the machine translated questions as linguistically correct and understandable. This shows that post correction or correcting the translations seems not to be necessary, at least for our tested languages. The scoring of the student answers was only rated average, as you can see in this figure. We learned that in case they didn't know the answer, many users had entered random answers and received points for this. This was because these random answers did not appear in the training data of our automatic short answer grading model and therefore could not be scored correctly. The training data was taken from exams, which usually where usually no student dares to enter, like in this example on the right, I don't know as an answer. Here we see, of course, room for improvement, for example, by including such answers that do not make sense in the training data, or with the help of simple rules that score such entries with 0 points. Our explainability approach with keyword highlighting was well rated. However, we did not, as you can see on the right figure, however, we did not get as much feedback on it because it was only implemented and tested in English so far. And how was the feedback on the learning experience? These 4 figures show that participants responded positively to questions about improving the learning experience, meaningfulness, use, and helping fellow students, both in general and for our implementation. The majority also believe that our implementation can accelerate the learning process and that scoring other student answers is helpful. But there's a more divided opinion on the questions, whether the exam trainer is good to get familiar with the subject in the native language first, when the actual exam is in English anyway. What you can see below on the left-hand side, and whether it can help elderly people to study online, what you can see on the right-hand side below. Now I will sum up and indicate possible future steps. I have presented a multilingual, interactive, conversational AI tutoring system for exam preparation, which combines multilingual NLP components, automatic short answer grading, conversational AI, keyword extraction, learning analytics, crowdsourcing, and gamification. With this multilingual exam trainer, we received positive feedback in a survey regarding learning experience, user experience, motivation, quality of NLP models, and gamification. The results of our survey support our proof of concept, where users have tested 6 languages so far. So future work may include the extension to other languages. In addition, we would like to further address the issue of explainability to provide even better support to the users of our multilingual exam trainer. And to optimize the dialogue, it could be investigated how to create a more emotional dialogue in a written form, for example, by visualizing voice characteristics and emotions in the textual representation. Thank you.
Okay, thank you. Thank you for these very interesting presentations.
You're welcome.
So now we have some minutes for questions. I see a couple of questions from the audience here. I don't know if you are able to read that, but I can read them for you. One question is whether you could talk more about the performance of the automatic translation phase. Could you please add some remarks about this?
Yes, you are talking about the automatic translation, which means we use the Google Translate function, which is based on the neural machine translation system from Google. I don't have the Blues course in mind. I think I related to the two papers. Unfortunately, I have no problems to enlarge the screen in order to see you, but I will fix that. Let me just see. This is fine. This is fine. But I cannot enlarge it and go back to my slides. Can you see my slides? You can, right?
Yes, I can. Yes.
Okay, so let me just share them. And then let's close this. So so I have 2 numbers only. Well, I can have two. I have 2 sources. So you find, I don't know if you can see the pointer right here. Just see it. So in Wu et al. And Icahn et al., you find information about the Bruce course, which is the general performance. But what we haven't done is we didn't exclusively, because we relied on the machine translated text. We haven't, like manually corrected the translations. And then computed like a blue score or something or like a certain error metric of the differences. The only thing we did was that we asked the people how good the quality was of the translations in terms of have the questions been linguistically correct. That was one, and you can see here that most people strongly agreed, right? Covering those 6 languages which we used. And then what we also did is we asked if the native languages are kind of understandable. That was even also very good rated, a little bit better because more the bar at 4 is a little bit higher. Yeah. So we found when we looked into the translation minor errors. So for example, in German, if you talk to a Mr., you have a different form. You don't say you say like they, right? So this was not really perfect, and you know it from Spanish, usted, for example. This was not perfectly translated, but people didn't mind in that case. But of course, if I would provide a learning system, a real learning system for university, and it was not, research, then I would manually post correct that. But just to make sure that this is has been understood, for the multilingual short answer grading model, we don't touch any translation model or something. We can use we can type the question in the language which is covered in the NLP model anyway, in the whole NLP model. Yeah.
Okay. Actually, second question from the same person is about the same step, the same translation phase. And the question is this step capable of introducing noise that would hinder the automatic evaluation of the answer based on semantic similarity? I don't know if you understood this.
What? I can only see the two chat information. This was. Can you also add some remarks on the performance
of the first question? Yeah.
Using noise that would hinder the automatic evaluation of the based on the semantic similarity. I'm not sure if I understand. Like, I'm trying to understand that performance of automatic translation phase. This step capable of introducing noise. What do you mean by noise, and how do you want to introduce it? Are you talking about like an attack from outside in order to
get what kind of noise do you know?
Yeah, usually introducing noise that would hinder the automatic evaluation of the answer. You mean, for example, if it's grammatically not correct, for example, or if you have like filling words which do not really here she. Yeah. I mean imperfections in the translation. Just to make sure if that is understood correctly, let me just switch to that. So what is translated by the model is only the, like here, this. So for example, this is it's Dutch and English. So English is translated into Dutch, and this is just being translated. Sometimes the context information is missing, and so this is why it has to be kind of corrected. So sometimes it has the Mr. form and then the U form. But what do you mean by really? Just reading it. Mean imperfections in the translations. Noise that would hinder. Everything.
Maybe a question is whether the user, the student, inputs some problematic text. I mean, in terms of bad grammar or bad syntax, and how the system is dealing with that, or how maybe you have language checker.
Yes, I also like the problem very much because I think, sometimes a corrector thinks someone is a bad student if he is not grammatically perfect. And this is not true, right? So sometimes they write, there's a bias, there are papers about this. And I would love to test that. I haven't tested it yet, but I think since we are working with a vector space, as I told you, the whole sentence is built with a vector space. Do I have it right here? But now I know what you mean, most likely, hopefully. Yeah. Here, for example, so if for example, honey is misspelled or something like this, right? Or there's a wrong grammar, then there is still a vector in this vector space, which is close. So it is still possible to create that wrong sentence, grammatically wrong sentence, because it builds a semantic vector space, which has, the meaning is in the same position, the same meaning, the same words, like synonyms, as I mentioned before, are in the same area. So it is kind of a little bit proven, right? So I would say this is possible if it's not completely out of, completely the wrong words or the wrong grammar, then it might be also possible. But I haven't checked out how far the distance to a linguistically good answer of the students can be in order to still have good accuracy in grading. Yeah. Okay. I hope that somehow answers the question.
I think so, of course, understood. Thank you very much. So we have time for the last question. I don't know if you can hear the question from the chat. So the question is whether use your approach as a dialogue partner, for example, in problem solving, where the user will be hierarchically guided over several levels to the core of the required information, which is the problem, while checking over questions, whether the user is still on the right path. Well, it's actually interesting, complex question. Maybe
yes, I'm trying to. I'm just reading it. Could you imagine also if the approach is dialogue partner, for example, in problem solving? Well, each and every chatbot or conversational AI system can be used as a dialogue partner, and that's for sure. Whether the user would have hierarchically guided, and that could be also because you can define the dialogue flow hierarchically. That's also possible in conversational AI systems over several levels. Yeah, to core of the required information problem. Yeah, that's possible while checking over questions whether the user is still on the right path. Yeah, there have been systems which work in such a hierarchical way. I don't have the references here in my presentation right now, but so for example, there are chatbots which help patients in the medicine domain, for example, and they are also working on such hierarchical information, and based on the answer, they go different directions and ask other questions in order to get more detailed information of the patients. And this could be within another each and every learning system. It could be also implemented. Yes, I can imagine that.
Okay, I think it was understood. So, well, I'm sorry because the time is up now. We need to move to the next talk. So thank you very much, Professor Tim Schlippe, for your very interesting, inspiring presentation. Hopefully we can talk later about some details because I actually have some questions for you. I write to you an email or something. But now we need to move to the next talk. So thank you very much.
Yeah.
And now.
Appreciate that. Have a great day, guys.